In this video, we're going to talk about symmetry. And symmetry is probably something that you have learned about before or talked about before, and we're just going to add some new vocabulary to the idea of symmetry today. So symmetry, in our class, we're going to talk about two different types. So we have reflectional symmetry, which is when we have the lines of symmetry. So lines of symmetry is probably what you're most familiar with knowing and learning. So when we look at these shapes, we would say this arrow right here would have one line of symmetry. All right. And what you want to think about is if you were to fold a shape over the line of symmetry, would it overlap itself perfectly? So this is definitely one line of symmetry. It's creating two halves. So we would say one line of symmetry here. All right. Now, if I look at a square, and I'm going to go ahead and mark this as a square. All right, we can see the 90-degree angles, but let's just put all the markings in. If this is a square and I wanted to count up my lines of symmetry here, then I would see that I have, and let's go ahead and do this pretty turquoise color. I would say I have a diagonal line of symmetry. That's one. I have along the other diagonal, that makes two. I have down the middle, and then I have across here. And I'm just going to move these over a little bit so it looks good. All right, and those are my lines of symmetry. Now, be careful when we count our lines of symmetry. Don't go all the way around because some of these are repeats. So I have 1, 2, 3, 4. I'm not going to count this one because this one we already counted. So in a square, we have 4 lines of symmetry. And this is all reflectional symmetry because if you were to take this, it's cutting it in half. If you were to put or fold this square along any of these lines, it would overlap itself perfectly. And then again, let's call this a regular pentagon because that just makes it a little bit easier. And we're not always going to do that. And we'll do some examples where we're not assuming they're regular. But for these, let's go ahead and put in the regular lines. On a pentagon, I see a regular pentagon, one line of symmetry. And then we're actually going to call all of these lines of symmetry. So that's 2. I could have 3 here. And then I would have 4 here. And I'm just going to fix the one that's a little off. Okay, and so on a pentagon having 5 sides, a regular pentagon would have 5 lines of symmetry. So one good thing to realize is that if I have a pentagon, regular pentagon, 5 sides, 5 lines of symmetry, a square, which is a regular quadrilateral, 4 sides, 4 lines of symmetry. So symmetry along a line, reflectional symmetry, is probably the one you're most comfortable learning about. You've heard about it before. This is our line symmetry, one line of symmetry for each of these shapes. But then in this class, we're also going to learn about rotational symmetry, which also goes along with point symmetry. All right, now in our rotational symmetry, we're going to look and we're going to ask ourselves, if I were to start to turn this object, how many times it would overlap with itself? So we're going to come back to those shapes. I want to look at these first. So rotational symmetry occurs when an object can be rotated 180 degrees or less and still land on itself. So you guys don't have this capability on your papers, but what you can do is just take out a scratch sheet of paper and trace a shape and look at one corner of it. So if I were to think about this corner right here, and I want you guys to actually highlight a corner when you trace it, if I start to turn it, right? If I start to turn it, it has now overlapped. So that's one. And then if I go again, that's 2. If I go again, it's 3. And then if I go my last time, then I have now returned. So this is something we would call 4-point symmetry. It took me 4 turns to get back to the same shape. So 4-point symmetry, or we call that 90 degrees. If you guys look, if I rotate again, I would have gone 90 degrees to get here. So 90 degrees or 4-point rotational. Because remember, when we're talking about rotating, it's 360 degrees in a circle. Now, not all shapes have point or rotational symmetry. If I look at this, I could go all the way around and I don't ever get back to the same shape until I'm here. So this object has no rotational symmetry. All right. So if I just go back and I look at these two shapes here, this sun, if I focus in on just this point, I would go once and I would get to here, 2, 3, 4, 5, 6, 7, 8. This has 8-point rotational symmetry, or if I did 360 divided by 8, 360 divided by 8, we would have a 45-degree rotational symmetry. This one, once, twice, 3, 4. So this is 4-point, or 360 divided by 4 is our 90-degree rotational symmetry, 4.90 degrees. All right. Now, here, this is what we would do to figure out a shape can have both types of symmetry. All right, so if we just take a second, I want to look at a couple of these in this table. If I'm looking at a rectangle, in a rectangle, we can't have a line of reflection over the diagonal. And I just don't draw this in on your paper. I just want to draw it here quickly. This, if I were to reflect it, this point would end up down here. It's not a perfect match. So therefore, we have to say that a rectangle, and I'm going to move these out of our way now, a rectangle actually only has 2 lines of symmetry, and I'm going to draw them in for you. We would see 1 and then 2. So we definitely have 2 lines of symmetry. Now, if I rotate this shape, I'm going to just take a second and do a quick, and this is what you guys would do with a plain sheet of paper. Just trace over the shape, and then you want to rotate that. So if I start to turn this tracing, I'm not, so it's definitely not 90 point, but then look, if I'm here, I've overlapped it. So that's 2-point rotational symmetry. So that's what we're filling in this middle one. 2-point, and I put this 2 in the wrong spot, so I'm going to move it up here. And so what this part means is it overlapped itself at 180, and at 360. I'm going to draw that a little nicer too. My pen got stuck. All right. So we would say 180 and 360. Does this figure have point symmetry? Yes. If it has this, then it does. So this is one that has 2 lines of symmetry and 2-point rotational symmetry. Now, when I'm looking at this shape, this is a 1, 2, 3, 4, 5, 6, 7, 8. This is an octagon. So when I start looking at my octagon, I would say 1. And then we're also going to have a line of symmetry over here. I'm going to use my line tool instead because this is going to make a mess. So, okay, here we go. So I would have 1, 2, 3, 4, 5, 6, 7, 8. So notice for an octagon, you have lines of symmetry in between the vertices and on the vertices. Also, if I were to start to pick up this, it would overlap itself here, 1. It would overlap again here, 2, 3, 4, 5, 6, 7, and then get back at 8. So this has 8-point rotational symmetry. So that means at every 45 degrees, we are rotating. So you would write out all increments of 45 until you get to 360. So 45, 90, 135, 180, 225, every 45 degrees. 25 plus 45 gives me 270, to 315, to 360, which means yes. All right. Now, in this shape, this is a, let's count, I'm going to do one last example with you. 1, 2, 3, 4, 5, 6, 7. This is a heptagon. If I start drawing in my lines of symmetry here, I see 1. And so then I could go from the vertices here, 2, 3, 4, 5, 6, and then the last vertices 7. So we have 7. Oopsies. So that's 7. And so then take a second and think about what this would mean if you pick up and turn each of the vertices. And then to figure out your point symmetry, I'm going to let you guys do this with your calculator. You have to do 360 divided by 7 to see the increments that it's growing. All right. Now, the last one, the arrow we already talked about, has 1 degree of rotational symmetry, one line of symmetry. But then if I pick this up and turn it, I have to turn all the way around to get back to the original shape, the degree of rotational symmetry. So this actually has none. This is no point symmetry. If you have to go the full 360 to get back, you definitely say no rotational symmetry, no point symmetry. All right, so go ahead and finish filling in this worksheet and then try the rest of the symmetry problems on the next page.